Good afternoon, everyone. Welcome to this session on financial data analytics for capital markets with the Goldman Sachs Legend platform. I'm Gerard Cowburn, a senior solutions architect at Amazon Web Services in our global financial services practice. With me today are some colleagues from Goldman Sachs: Rajimoni, Vice President and Tech Fellow; Anusha Cheda, Data Engineer; Nick Hoffbauer, Vice President; and Emily Menzies, Executive Director. Thank you all for joining us here today. Today we're going to demonstrate how we brought together two powerful platforms to deliver faster time to business value with reduced engineering effort in what has traditionally been a complex and challenging environment. The first of these is the Goldman Sachs Financial Cloud for Data, announced at reInvent last year. FinCloud brings together Goldman Sachs' own curated datasets, a time series analytics database specifically designed to deal with the complexity of financial market data, and a data modeling, analysis, and visualization platform. The second of these is Amazon Redshift, our easy petabyte scale relational analytics engine. We've made a few really exciting announcements about Redshift here at the New York Summit today, which I'd encourage you all to check out if you've not already seen them. One of these is the general availability of our serverless offering, and another is the launch of our Powered by Redshift initiative for partners. Redshift has two powerful integrations that play a key role in the demo you're going to see here today. The first of these is data sharing with AWS Data Exchange. Data Exchange provides access to over 4,000 datasets from over 250 vendors and has an easy data discovery and subscription workflow. It provides access to data through S3, Redshift, and API-based delivery mechanisms. Using AWS Data Exchange for Redshift, you can run analytics seamlessly across first-party and third-party data, all within your own Redshift instance on real-time data without any complex data sourcing or ETL processes required. Data Exchange reduces the cost and makes it quicker and easier for businesses to source data, enabling you to innovate faster, be more agile, and deliver your business results more effectively. The second powerful integration is Amazon Redshift integrated with Amazon Sagemaker, our machine learning platform. This integration enables you to run machine learning training and inference directly from within Amazon Redshift using simple, standard SQL queries in a familiar interface. Redshift and Sagemaker take care of moving the data, pre-processing it, and tuning the model regardless of your own level of expertise of machine learning, enabling you to get started with machine learning really quickly and easily. Redshift offers the best price performance at any scale and is ideally suited to handling the complex analytics required in high velocity, high volume, and high variety data that we're used to seeing in financial services. I'd now like to welcome to the stage Rajimoni from Goldman Sachs, who's going to tell us a little bit more about how he brought these powerful platforms together to solve a business problem that we'll introduce you to. Thank you, Ram.
Thank you, Jared. Thank you. Each of these platforms is actually powerful in its own right. The all-powerful clicker. On the Legend side, there's on the Goldman Sachs Financial Cloud side, there's curated data that is coming in. On the Redshift side, you have the ability to perform analyses along with machine learning and other aspects. So what we're going to show you today is when these platforms have their own data sets and their own capabilities, how do you bring them together in a seamless manner with as little pain as possible? So to do that, what we are going to do is pick up a particular problem, and when you look at these platforms with their abilities, and you think about how to bring them together, it's not straightforward. We're going to show you why it isn't straightforward, and then we're going to pick a particular problem, and this problem has to do with the crypto domain. It's just a problem that we choose to paint the solution and the picture we are about to show you. And this shows, we asked the question, if we were to look at market data from curated market data from the GS Financial Cloud, and we look at information from the Amazon Data Exchange, the AWS Data Exchange, and we want to do some kind of analysis with these, what would be a good place to do them? How would we do them? How would we look at the analysis? How would we look at the results? And then how do we bring them all back together in a place where we can do further decision making? So the journey starts with data sets. And to introduce to you the different data sets we're going to use to solve this problem today, I'm going to introduce Emily Menzies, who's going to walk us through both the marquee financial cloud, the Goldman Sachs Financial Cloud for data, as well as the Amazon Data Exchange aspects pertaining to our particular problem today.
Thanks very much, Ram. So as Ram mentioned, we wanted to give you a real world example today, and we settled on cryptocurrency because it was our belief, our assumption, that this was indeed a topical and an interesting asset. It's interesting because it's so volatile generally, but also particularly volatile in the last handful of weeks. And so to start, we go to marquee.gs.com. Marquee is Goldman Sachs' digital storefront for our institutional clients. It delivers market insights, execution services, analytical tools, data and developer services to our clients directly via a suite of digital solutions: desktop, mobile, web, programmatic API interfaces. So on Marquee, I can enter a basic search for maybe the best known cryptocurrency, Bitcoin, and I can filter my results by research and insights. The top result here is an interesting one. If we go into that article, we can see that the headline of this article is speaking about Bitcoin dropping below 20K for the first time in well over a year. So now my interest is piqued, right? I'm intrigued, I want to delve a little bit deeper. And to do that, I go to Plot Tool Pro. I go to Plot Tool Pro to visualize the data itself, to dig into the analytics and to understand what's driving these headlines. Plot Tool Pro is Goldman's display-based time series analytical tool. It's actually based on the most popular trading app on our trading floor, and it enables our institutional clients to create bespoke visualizations using a vast array of analytics functions. It enables our clients to visualize complex market dynamics, to evaluate and to share ideas, and to backtest trading strategies. Plot Tool Pro is cross-asset. Currently, our greatest coverage is in equities. We're expanding into FX, into rates, into digital assets like cryptocurrencies. And we have a quick start bar. So if Ram navigates to that, we can see that within the quick start bar, just beside my plots for me, Ram. Whoop.
Oops.
So staying in Plot Tool Pro, just beside my plots, we have a quick start bar. Lovely. And the quick start bar shows us the pre-programmed plots that you can take advantage of. Plots that our traders use most frequently for their own internal research and also for their interactions with clients. But way more fun, and I think Ram was ahead of me, to start our own plot from scratch. So let's go to my plots and we'll do exactly that. So in my plots, I'll start from scratch. I start by selecting the asset I care about, Bitcoin. And then I select a measure, spot price. And immediately the chart will load and I can see exactly how volatile Bitcoin is. Huge volatility over the last year, and honing in just on the last 30 days, maybe around the last month, thank you, I can see exactly where cryptocurrency plummeted to below 20K for that first time in over a year. Pretty cool, but let's do a bit more. Let's add a second measure. So Bitcoin again, but this time looking at the 30-day return on your investment. So adding that plot to our chart, first thing you see is not particularly helpful because you can't plot percentage returns on the same axis as a $20,000 price point. So Ram kindly changes the axis for me, and suddenly this makes a lot more sense. Suddenly even I can see how closely correlated your Bitcoin spot price is with your 30-day return. Let's go a little bit further and use the pre-programmed correlation function to view this in more detail. So Ram kindly sets our variables. X is spot, Y is the 30-day return. He executes the beta function, the correlation function, and I think hide for me the X and Y variables because we don't need those anymore. So hiding those X and Y variables, we now just see the beta. And you can see kind of expanding again, 6 months, a year, thank you very much. We can see that, yes, there is a really high correlation. It's almost typically perfect, but we still have really interesting peaks and troughs, right? Points in the data service where your return deviates from the current spot price. Ram, anything else you'd like to see?
Well, this is very interesting, but we have to help our friendly Bob, we have to kind of mix this up with some other data. And I was just thinking, something with social media?
Love it, almost as if we'd pre-planned this. So Ram, if you could kindly just save the plot for me, and afterwards, because I have the memory of a goldfish, share it with me. That big button on the top right allows you to share your plots with any of your internal colleagues or external clients. But pivoting away from Plottool Pro for now, we'll switch into the AWS Marketplace. And I use the AWS Marketplace like a catalog, something I can self-service and search for publicly listed data products that I can use to supplement my existing knowledge. So Ram kindly goes into the AWS Marketplace.
Aha. The first aspect of a live demo, we have been logged out. Let's get ourselves back in.
Better. So within the marketplace, like we said, we can search for publicly listed cryptocurrencies, see what's available currently. So in the search bar, thank you kindly, just enter crypto in the search bar, and we can see all the publicly listed cryptocurrencies. We'll use Marketplace, as I mentioned, to search for all the available publicly listed services before ultimately choosing to subscribe to one of the available products or to a privately listed product via AWS Data Exchange. And we're really excited about AWS Data Exchange once we're logged in, and AWS Management Console, because it's allowed Goldman's to build event-driven pipelines that create a scalable, automated, and process-driven solution for consuming data services. It allows us to avoid wasted developer effort in consuming those services, wasted extract, transform, and load services. So Ram is now kindly in our AWS, he's going to go into our AWS Management Console for me. And within the AWS Management Console, you see the service that we've found and we've chosen to supplement our existing knowledge. The service we've chosen is a Rayark service. It's a cryptocurrency sentiment service, which coincidentally is delivered via Redshift, which is our preferred delivery mechanism. Redshift is our preferred delivery mechanism because it allows us to directly query the producer's data services, reducing latency, and also to only pull the changes or the updates that we care about, the fields that we care about. So this specific service is an indicator of public sentiment in cryptocurrency. Rayark curate a sentiment score between -1, the most negative, +1, the most positive, and they do that for both Bitcoin and Ethereum using keywords in tweets over the last day. Keywords in tweets that are then refreshed on a daily basis and made available to us. I won't go into too much detail because I know we've got Rayark here with us today and people can find them afterwards to go into much more detail than I can give you. Ram, with that, I think I'll hand back over to you and let you go back into ingestion, modeling, curation.
Thanks very much. As Emily pointed out, there are Rayark people in the audience. If you want to talk more to them afterwards, please find them. They'll be sure to help you. So let's kind of do a little recap. What we have right now is the semblance of an idea. We have the market data from curated market data from GS Financial Cloud. We have the sentiment data that is coming to us from the Rayark side, and we somehow now want to mash this up together. So let's just pause and think about that for a second, right? In general, what this involves, and this is generally the point where reality sinks in, how do you source the data? The data lives in different places. How do you model it? The vocabularies are different. How do you bring them together? How do you perform the ML analysis? And then last but not least, how do you get the results back into GS Financial Cloud so you can then do further analyses and further exploration with what you've just done? Now, until now, this is very hard to do, right? What you end up having to do are bespoke pipelines that you have to create, manual coding, usually orchestration that is done by hand, and then these are done in different dashboards, different tools, different consoles. So at the end of the day, as a person who might get confused, this is very hard to all keep track of together. Most importantly, it is not something that is easily done by non-experts. You need a priesthood to do this before. And what we're going to talk about today to you is how we've solved this particular problem, in our case, by using the Goldman Sachs Legend project, which is brought out by the FinOS Foundation. And this project is helping us to integrate these two powerful platforms, Redshift on one side and Financial Cloud on the other, to help us seamlessly move data as well as do these analyses across one another. Now, Legend has been talked about before, and there are a lot of YouTube talks and other media that explain to you what Legend is, and I kind of really encourage you to go and learn about it. But at its heart, Legend is really a data management platform. What it lets us do is focus on problems that are important to the financial domain. Here, it's not the volume of data that matters. What really matters is the complexity of the data and the fact that there are multiple actors, and these actors often need to be brought together to kind of handle the data problems that we have. There's four main things that Legend does for you. Discovery, that lets you, a non-expert, easily and quickly find the data. Transformations, which is the ability to move from one form of information to another, along with the ability to capture lineage as that is being done, and then have that lineage be used to further work. There's an aspect that pertains to data quality, where you can add these constraints and checks and other things inside your processing pipeline, so you get feedback as to how things are going as they happen. And last but not least, on data delivery, where you can safely acquire this data and then use it in the analysis that you want to perform. So to kind of put some of these things into practice, I'm going to bring up to the stage Anusha Cheda, who's going to help us work with Legend Studio and construct a small project that brings some of these principles kind of to life. Anusha, shall we kind of work with Studio a little?
Yeah, thank you, Ram. So right now on Legend, we're going to create a simple service that reads from a Redshift table and models it into as something like what we as consumers want to see it as. So let's go into Legend, create a new workspace. Let's call
Excuse me. Let me authorize myself again. Another
Sure.
live demo. Go ahead.
Okay, so let's create a new workspace so that we can start from scratch. Let's call it demo.
Call it demo, okay.
Yep. Enable group workspace, create. And let's now go inside it and begin editing it as soon as it loads.
Okay.
Okay, so let's say we want to model a class person, which is logically mapped to a relational table in Redshift called person database. So let's start by creating a new package called simple service. Create. So we need like a connection to connect to Redshift. So let's go to the plus arrow and create a new connection called person connection, which maps the person classes. And create.
A relational connection?
Yeah.
Okay. Do you remember these parameters?
You know what? It's a little involved details to type in right now. So why don't we switch tabs to a workspace where we already have filled these details out?
I like that idea. A cheat sheet.
Awesome.
Okay.
Yep, I think it's called simple service demos. Okay. So we've already filled out the connection details, and we also have, you can see these like the port, database, all of that. And we also have a person DB schema set up, but it's empty right now. So we need to query Redshift and get the entire schema from it. So go to the store tab, click on build database. It shows us the databases that we have on Redshift currently. Expand that, and we can see the person database that we require. Okay, let's click that icon and that'll create the schema. And we can now just save this information in our code by clicking the save button. Awesome, it's now saved in our code. So now let's create the actual model class called person. Create a new class, please, thank you. Called person. We can add properties to this class. So let's add two properties called first name and last name. And they both will be of type string, but Legend also allows us to have lots of other primitive types, including the ability to have nested embedded objects. For now, let's keep it simple, have first name and last name as a string. We can also have derived properties if we want. Okay, now we need an actual service to execute, and the service includes a query, a runtime, and a mapping. So let's create a new service.
What would you like me to call it?
Let's call it Redshift read.
Okay.
So this will actually query the database, get data for us, and we can map it into our model class person. So let's try writing the query. Edit query. Okay, look, Legend tells us that we first need a mapping for this. So let's create the mapping first. Let's create a mapping called person mapping. So we can add a mapping element. Our target will be the person class that we've created, and once we create that, we can edit the source to be the person database that we have in Redshift. Awesome.
Which changed you to relational, and that's fine,
yeah,
right?
Awesome. Yeah. Perfect. And we can just simply drag and drop and map the elements as we want. So let's map first name to first name and last name to last name. Perfect. Okay, now I guess we can go back to the service and create a query and a mapping and a runtime. Yeah. So now we can write the query. Let's edit the query. So we can switch to graph fetch, the graph fetch tab on the right. Yep. And we can fetch the first name and the last name. That's what we want to display at the end of our service. Awesome. And let's save that and save query. That gets saved to our code. And now we'll need a runtime. So let's create a custom runtime there. Yeah. And we can add our connection that we've already pre-filled out into the connection into our runtime.
Okay.
Yes, so there's all the information that we have, and now I think we have all the elements in place that we need to execute the service. So let's go ahead and execute.
So when we do execute, what exactly is it going to do?
So it's going to display first name and last name from the Redshift table person database.
Nice.
As we have modeled.
Nice, and it's doing this all through the model that we just created, right?
Yes.
Perfect.
Exactly right. Awesome.
You can see our team there, along with Bob, our mascot, the sad, puzzled, confused, happy person. Thank you, Anusha.
Thank you.
Yeah. So Anusha has given you the basics of how to do the work with Legend. And what we're going to show you now is how to bring some of these principles back into bear for our particular problem at hand. So let's just do a little recap, right? What did we want to do? We want to pick data that exists in the financial cloud side that Emily talked about with Plot Tool, and we want to bring the data into Redshift. So how do we go about doing that? So in the Legend world, we are now introducing a construction called persistence. And persistence, the act of persistence or the act of persisting speaks to writing data. So we have a project that has already been created that shows all of this information here. Let's actually look at one of these persistences and kind of see what it does for us. So on the left-hand side, you'll see how I've arranged this project. It's fairly, for a non-expert, it should be fairly intuitive and easy to see. We have kind of 4 modules that we've done. There's a part that deals with moving data from ThinCloud into Redshift, which is the from ThinCloud. There's a part that deals with the actual models of the data, which is the raw crypto market metrics data, the ML prediction that we're going to do after everything is done. There's an aspect that deals with the Redshift part itself, which is inside Redshift, we want to do some work, and that's that part right there. And then finally, we have an aspect that deals with moving everything back into ThinCloud. And I'll walk you through this, and you'll see how easy, pleasant, and logical it all happens to be. So let's start with the notion of moving data from Financial Cloud into Redshift. So as I mentioned before, the grammar construction we use in Legend to do that is called persistence. And this construction here, this section here describes that we want to perform a service, which is a model-to-model transformation from the data that lives in Financial Cloud into the vocabulary that lives in the Redshift side. As input to that, we want to perform the Financial Cloud data as a connection, perform this operation in a batched manner, triggered manually. The sync is a relational sync, which is described by this Redshift connection. And while doing that, do so with no milestoning, which means that every batch of data overrides the entirety of the previous batch of data that lives in the database. And then the resulting target shape is flat, described by this PR model with a name and with no deduplication performed upon potentially duplicate elements in the incoming data. So this construction describes how we actually persist this information from the FinCloud side, Financial Cloud side, into Redshift. In support of that, we have a model-to-model transform. Let's take a look at that. And now with what Anusha talked about, this part should be fairly straightforward in that we actually know what we want to do there. So let's see that. And we observe that the model is what I'm showing you over here for the crypto market metrics on the Financial Cloud side. The transform has a mapping and a runtime. The mapping talks about how to move this data from the FinCloud side into the form that we want to represent it on the Redshift side. The runtime is a model store where the data comes from the FinCloud. There is a model store, and then it's actually taken back out into the Redshift world. I have to mention at this point in time that Legend is not a data analytics platform. It is an integration point, and so there is no, all of the work that you see over here happens in a streaming fashion. The data passes through. There is no actual store itself in the platform. What we now want to do is turn around and kind of see some of this in action. So to do that, I'm going to make a small change to this service that we've constructed, and I'm going to push that into GitLab. And then I'm going to call my colleague, Nick Hofbauer, to start coming up to talk about what happens behind the scenes when you make a change in the Legend Studio project. So let's make a change. Okay, let's actually compile it. Oops, compilation error. Let's fix that. We compile, and we have a change, and we're going to push that change. And this change is getting pushed into an underlying GitLab project. And the GitLab project backs the studio world that we have going on over here. And to talk about what happens in the GitLab world, take it away, Nick.
Thanks, Ram. All right, so let's lift up the curtain and actually see what's happening in GitLab, right? So we're not hiding anything from you here. Everything that was saved and designed in Studio is actually in this repository that you link when you create the Studio project at the very beginning, right? So you can see the pipeline running from this commit and this push from Studio. If we can actually show in the repository some of the models and services that we constructed in Studio.
Like go inside and see how some of these are actually stored in the world? Yeah. Yep. Let's go to our particular project. Which one would you like to look at? The persistence that we did?
The persistence one, yes.
Okay.
Yeah, yeah. Right, so exactly. So this is the exact persistence that we designed in Studio, right? So as you also may have noticed while Ram was browsing the repository, this is a Maven project, right? So if we go back to our CI/CD.
It's difficult for me to hear you, Nick. Can I have you come a little closer to me?
Yeah.
Awesome, thank you. Perfect. Okay. Go ahead.
I'm hoping everyone else could hear me. All right, so if we go back to CI/CD, to our running pipeline. Okay, so you can see that for this POC, we've designed a very simple pipeline. The first stage in it is build. So basically, I won't bore you with the details of the POM.NET XML, but essentially we're taking those models and services that we've constructed in Studio, and we're compiling them down to Java classes. We're also building execution plans for the various services. And we're also taking that persistence spec and creating a plan from this as well, right? So at the very end, we bundle all these up into jars, and then we move on to the next stage in our pipeline, which is our deploy stage, right? So this allows us to provision various resources in AWS that allows us to actually run this persistence, right? So what we chose here is AWS Glue, and more specifically, Glue jobs, which think of them as fully managed serverless Spark jobs, right? And I'll go into more detail when we move to the AWS console.
Perfect. Shall I go into the console for us to look at that over there?
Sure. Actually, before we do that, let's move to Legend Studio and execute this persistence.
Okay.
Yeah.
You know, I'm just thinking maybe we should wait for this pipeline to get done before we kind of execute the persistence, because it doesn't exist until the pipeline actually finishes executing. And as we speak, it actually finished. So let's go and do that. So let's come to the actual, this is the pipeline that is going to move data from the financial cloud world into Redshift, right?
Yep.
So let's actually execute this pipeline. Let's trigger it. What does this triggering do?
So basically, it's starting the Glue job that we provisioned, and I'll go into more details actually when we bring up the AWS console. So while Ram's doing that, in addition to the Glue job and the Glue trigger that allows us to actually start this the specific job, we're provisioning an S3 bucket that allows us to copy over those artifacts that we've built in that first stage, along with this generic Glue script that I'll show in the AWS console, and this persistence runtime library that allows us to actually run this persistence in AWS Glue, right?
Shall I go to Glue now?
Yes. Yep.
Okay.
And if we
Aha.
bring up the
I see it.
the job that we just executed, I believe it's this one. Yep. Exactly. Okay. So under history at the very bottom, you could see that we have a job run that is actually running right now. And we could actually dive more into this if we wanted to, into the logs and some various other things here. If we wanted to as well, we could actually bring up details and see the libraries that we're including for this job, the script, the configuration of Spark and other Glue things. And here we could actually see the script. And as I mentioned, it's a very generic universal Glue script that basically allows us to point to that persistence path, what we built in that first stage in the GitLab pipeline, and reference this particular persistence, right? And if you recall from that actual persistence, maybe if we can switch back quickly to Legend Studio and show that persistence. I believe it's the second tab. Yes.
Which is this one right here, correct?
Yes. Yep, exactly.
Yep. Perfect.
So basically what the Glue job is doing right now is it's extracting data from FinCloud. It's running our M2M Legend service against this data, and then it loads this back into Redshift, right?
Shall we take a look to see if it's done?
Yes. Yep. Okay.
And speak of the devil.
All right. So I guess we could in theory stay here on the AWS console and go to the Redshift query browser and see this data now in Redshift, but we cannot actually do this all from Legend Studio. So we created a Redshift service here that allows us to query the data that we just loaded from Glue into Redshift.
So let's just talk about what we've done, right? We've actually taken this data that Emily showed with Plot Tool on the financial cloud side, and we've just written the grammar construction for doing that inside Legend. And behind the scenes, you've had pipelines spin up, S3, IAM, roles, all that stuff kind of spin up for you. And then we've just effected a transport entirely from within Legend to get this data from inside FinCloud into Redshift. We don't know yet if it's worked, which is what we're going to check right now. So let's execute the service. And at this point, we actually see this data that is coming through from the financial cloud side. This is all the information that we want to do for our mashup that we want to do inside the Redshift world. It's pretty cool.
Awesome. Nice. I'll hand it back over to you.
Thank you. So at this point in time, we've gotten the data back inside the Redshift world. I've kind of shown you how pleasant it is for a non-expert to kind of work in the grammar, logical world, right? With the implementation, heavy lifting being done by Legend. And then have these constructions that help you describe what it is you want to do, with the implementation details being handled by the platform, which is really how we want things to be. Now, this data now lives inside the Legend, inside the Redshift world. At this point in time, we want to perform certain machine learning analysis upon it. So kind of talk about that part. I'm going to bring Gerard back to the stage to help us explain how in the Redshift world, we're going to take this market data, mix that up with the Twitter sentiment data that is there from the Rearc side, and then perform some ML on top of that. Shall we try it?
Let's go for it.
Okay.
Thank you, Ram. So just a quick introduction. I mentioned the Sagemaker integration with Amazon Redshift at the start of the talk. Just to remind everyone, Sagemaker is our machine learning platform that makes ML accessible to practitioners of all skill levels. And the native integration with Amazon Redshift means that you can train machine learning models and then run inference directly within your data warehouse using standard SQL semantics that you're probably already familiar with. Redshift and Sagemaker takes care of moving the data, the training data from Redshift into S3, having Sagemaker autopilot run over that data, do its pre-processing, train the hyperparameters, and then decide what type of model is going to be best to then use for machine learning on that data going forwards. Once that training is done, again, the integration takes care of compiling that model in Sagemaker Neo and installing it into Redshift to use for inference at any point in the future. The great thing about this is that the inference is then run on Redshift Compute natively at no additional cost. For more advanced practitioners, you can choose to specify the problem type or certain hyperparameters. And you can even use your own model developed in Sagemaker natively with bring your own model to Redshift. But again, the future inference is happening on Redshift's own compute. And finally, for the most advanced practitioners, you can use remote inference endpoints. So you can actually connect Redshift to Sagemaker to run inference on the most complex of models at any given point in time, again using simple standard SQL semantics. So let's take a little look at how Ram has compiled his model for the demo here today.
I will open up our Redshift cluster and we can take a look at what we've actually done over there.
Sounds good, thank you.
I don't think we want to run the training now though.
No, we're not going to run the training. So the training does take a little while. You know, machine learning training itself is not the quickest process in the world, but let's just show what we've done in advance. So we can see here on the screen a pretty simple SQL query. It just says create model. We've given a model name, and then we've provided the training data. So this is a standard SQL select statement. You could reference an entire table if you wanted to. That's the data that Redshift is going to export into S3 for Sagemaker to train on. We've given it a target, which in this case is a Boolean value of invest, which will be the thing that we're trying to predict. We've given it a name for the function, which is the user-defined function that will be registered into Redshift for future predictions. We've given it an IAM role, which Redshift and Sagemaker will use to interact with each other and with the data in S3. In this case, we've specified the problem type. Again, this is optional. We know that in this case we want to do a binary classification, so we've given Sagemaker that clue, but we could have let it work that out for us. And we've given it an S3 bucket, which again is where the data is being moved around through. So this create model script has been run a little time in the past, so we're ready for the demo today. But we can use this show model command to have a look at how a model's been created. We can see all of the input data that we've just talked through, but we can also see additional information like when the model was created, how accurate the model believes it is, and how long the model took to train. So this is amazing. Using literally one SQL command, Redshift and Sagemaker have worked together. They've extracted our training data, put it into S3, run a training model on it, created an inference function, and installed that back into Redshift. But now what? Let's take a look at Legend Studio, where we're going to bring back together all of the data from the market fundamentals data that we saw on Plot Tool Pro earlier on, plus the sentiment data that we've sourced via Data Exchange, and now the reference to the machine learning function to actually run the sentiment analysis, or run the prediction, I should say, of whether or not we think it's prudent to invest in the current market conditions. So Ram, if we could take a look at, I think, the persistence configuration for the...
Perfect, let's do that. Let's start over there and then come into this one, right?
Cool.
Great. So perhaps I can talk a little about how the join keys kind of look like.
That would be great.
So in the Redshift world, we've actually performed our machine learning work. It's actually done all through SQL expressions. So again, for a non-expert, extremely accessible. And then when we come inside the Legend world, we can express the fact that we want to take these two different data, these two different physical tables and with logical models in front of them, and join them together to get this composite that has not just the market information, but along with it also the sentiment and the actual prediction that it is that we're trying to do. And that particular join expression is expressed in Legend in this syntax, which tells us that we want to perform the join. And most interestingly, there is a service that encapsulates this, and that service can now be executed to actually go into Redshift and read the result of this training that was performed earlier. So when we performed this particular read ML prediction, as opposed to previously where we just saw the raw data, at this point in time we also see the sentiment, which is mixed in from the rearc sentiment data set, along with the actual prediction. And this, at this point in time, we've done the work we want to do. We've gotten the data from ThinCloud into Redshift. We've done the work we want to do in Redshift, and we're now ready to ship it actually back into the ThinCloud side. So let's give that a try, right?
Sure. I'll let you wrap that up and then see you in a moment.
Yeah. Rather anticlimactically, the rest of it is pretty simple to do because we've done the hard work already. We've constructed the PR models. We've constructed the services, the mapping, the runtime to bring the data from ThinCloud into Redshift. We've shown you what that looks like on the Redshift side. All we now need to do is to take it back to ThinCloud. We express it again using a persistence. And that persistence is expressed right here in a manual trigger with the service that reads from Redshift, bring the data in a batched manner into a sink that is the Goldman Sachs Financial Cloud using that connection. Please do so with no milestoning, override the data every time. And when you do so, make sure the target shape is flat as described by this PR model and perform no deduplication. So again, a very simple expression of the intention of the person running this work. As with the case where Nick was showing it earlier, we can come back and trigger this work. And this trigger is going to pick the ML prediction we just showed earlier and then transport that back into ThinCloud, where we can then look at it using Plot Tool and other constructions. I want to point out something interesting here. something interesting before that. You can see that when experimentation is done on a Sunday to make the demo better, things usually don't go well, and that is actually what happened over here. But it proves the point that the setup is able to handle both exceptions as well as actual operations that take place. When you come in and look at this at the service that we have here, it has both a mapping and a runtime. Both of these are happening against the Redshift world. Let's take a look again at the glue console that Nick was showing earlier to see what stage this particular move from Redshift back into ThinCloud looks like. We can see that. Let's go into glue. Take a look at this pipeline. This pipeline is still running. It has the same script as was explained earlier, with all the jars and other things being done by the GitLab build pipeline. And as soon as this pipeline finishes running, we're going to be able to get into Plot Tool and look at the results of our ML prediction. So I want to take a small digression here. You might have seen 5 people kind of come to the stage and kind of leave the stage to explain this to you. It does not take 5 engineers to do this work. To implement the work takes a lot more, but to actually use it it's meant to be used by non-experts. So you don't need the level of extra engineering heft that is required to do this. To use this thing in practice, it's actually much simpler to use than you might actually believe by seeing multiple people walk up here on stage. This pipeline is finished running. We can now go back to Plot Tool Pro. And in Plot Tool Pro, we can take a look at both our 30-day return, which is what we looked at the very beginning with Emily, except this time we have an actual prediction. I want to stress that there is no alpha in this data. This is an exercise. It's just a hypothetical exercise. We've put together an ML prediction to kind of see what this looks like. And the prediction model tells us to do certain things which are, as I pointed out, have no alpha in them. But you can now see how all of this work from ThinCloud into Redshift, ML, and take it back all comes together. I'd like to bring up the rest of the crew up on stage while we kind of explain to you again or summarize to you again what we've done. We have a method that is going to make Bob happy. It's far less problematic than what we had before. It's an iterative development cycle. Legend has the ability to construct tests and have these tests execute as you commit. So there's a ton of things that we haven't shown there. All the results can be seen from one place. And at the end of it all, we have a very pleasant way of getting this all done. Thank you all very much.
Thank you, Ram. I love that we've just been able to get through from sourcing data, putting it together, running machine learning on it, and then getting to a business outcome in less time than it would typically have taken to just talk about thinking about sourcing data. So we've put a few links up on the screen here if anyone wants to follow up. We've got the legend.finos.org site where you can learn all about Legend, and then a couple of links to the GS datasets and to Redshift Data Exchange and machine learning. I'll give you all a moment. I can see a few cameras in the audience. Most of this, of course, you can search for as well. But and as we mentioned earlier, feel free to grab us afterwards and ask any questions. One final thing to leave you all with, I'd recommend everyone check out our skills and certification journeys. Skills Builder provides access to over 500 free digital courses across all levels of capability and including specialisms like machine learning and data analytics. And when you're ready, check out the certification journey. We have 11 certifications available from practitioner through to professional, and again, including specialisms such as networking. I'm over halfway through this journey myself, and I've really found that it's helped me to improve my confidence and my credibility in the industry. Thank you all for joining us here today. Please do fill out the session survey. All of your feedback is really highly valued and much appreciated. Thank you.
And we're going to be here for you to answer any questions if you have any. Thank you.